Right, so this part is just turning this in on Tuesday. And like I said, it's just committing to what 4 questions you're going to use. Make sure you do not use anyone the same as people around you. And answer those quick questions on pi and proto charts. So that should take you like almost no time at all, like maybe 3 minutes, 5, might be typical. All right, our exam 1 in class, a week from Tuesday, covers chapters 1, 2, and 4. Look at the study guide in the back to see what topics we're going to cover. If you do the study guide, the answers to the study guide are on Canvas, Canvas Study Guide Solutions. So go there. You should bring the following things to the exam. Make sure you bring all of these things. A pencil, a half page, one-sided of notes. So half page meaning a half of a 8.5 by 11 sheet, right? Not half of some giant sheet, but half of one of these, right? And if you want, you can just take a regular sheet and fold it up and use half, because I just realized what people can do, and some people do is, I'll let you use one half for this exam, then the other half for the next exam, and then flip it over and use this half for the third exam, and then this part for the final. So you can just, you don't have to tear it up, you can just use one blank sheet and just use that first fourth of it for this exam. It has to be handwritten by you, not taking other stuff and photocopying and shrinking stuff, because the part of this is the process of you figuring out what should be on there. So what I did when I was in grad school is I'd put down a bunch of stuff onto papers and then go through those as I'm studying, and then I go through those and figure out how to reduce that, what things I really, really didn't need, things I really did need, and kind of combine them and sort them out in ways and organize them to get onto this half sheet. And that process of doing that helped me learn the material better, kind of organize it in my mind, so that I didn't really look at the hardly ever at all, a little bit once in a while. So that's the idea, is that you'll learn a lot just by making this sheet, which is why I let you guys do it. Okay, you can also bring scratch paper. You will need at least a basic calculator. You can have a fancy one if you like, but no cell phones as calculators. But you do need a calculator. A dollar calculator is probably the most you really would need. You're fine with that. You also need to have your binder in order if you want extra credit. So you'll have 2 sections of your binder. It has to be, it has to have, where is it? 3 hole punches. So this binder is fine because it has 3 hole, everything I give you is 3 hole. So that way you can, put it in here and I can flip through it. I need 1 section for quizzes, and then give me a sheet or colored sheet, or even just a regular sheet folded over, to split them off between that section and the next section, which would be all of our in-class notes and quizzes that we're doing. In-class notes and labs that we're doing. So the chapter 1 lab, the chapter 1 notes, chapter 2 notes, chapter 4 notes, those I want in 1 section, in order, completed. Even if you weren't here, if you were absent, not my fault. You're still responsible for that material, right? Do it. Quizzes, all of them done, completed, right? And again, if you weren't here, you still have to do them if you want the full points, because it's still part of the course. And that for that you can get up to 2 points extra credit if you have them all completed and in order. If you attend 2 smart shops, you can get 1 extra credit for 2 smart shops. You'll give me your 2 little attendance slips. I'll take them, I'll tear them up, and I'll give you +1 on your exam for that. Bring those to the exam. Also, if you have tutoring sessions, then you can get, if you have 4 hours of tutoring, then you can get 1 point for that. Or if you're in a support course. So you can't get tutoring and support course. Support course kind of covers sort of the same sort of idea. So that one, if you are in a support course, write down support course on your exam, and I'll look it up and confirm that you've been attending, and I'll give you 2 points for that. All right, so those are all the ways of getting extra credit. My friend Jim Hannon, I've talked about him. He's that stat guy who worked for decades at Lawrence Livermore Lab and convinced me, that really this is how people do it in the real world, that guy. He is willing to tutor you guys, my students, if you have any questions or want help. He will be in 600, which is right across the way over there, on Tuesdays from 4 to 5:30 to answer any of your questions about statistics. So if you have anything in there, just go in there, and he's there to help you guys. He will help other people also, but not everybody knows about him. I've sort of wangled him and convinced him to volunteer his time for me, for you guys. So he's in there. If nobody goes, then he'll stop doing it. If a lot of people go, he'll do it on Thursdays also. So that's how that one works. Also, one of my former students is in this room over here, in the glass room over there. I don't know which glass room, but one of these glass rooms over there. She's in there from 2 to 5, I think, on Tuesdays, Thursdays also. And also in the mornings at some point. So that's another option. Yes?
Jim's retired?
Mm-hmm. Yeah. Yes. And let me know, like sometimes he's really passionate, so he might explain more than you need. Let me know if that's happening, and I'll kind of talk to him about maybe trying to like condense it quicker if that's happening. But no, he knows his stuff really well. Good deal. Oh, and if you do that, there's a sign-in there. And so how you get credit for that is you sign in. The beginning, there's a 202C class that people, if you go right in at 4, I think until 4:15, there's a class that they can show you how to sign in for the class, or talk to me about how to sign up for NMAT 200, and we can get you signed up for it. And then you sign in on the STARS machine there, and that's how we keep track of when you do those hours. I think the first one you may have to sign in on a Google Sheet instead. Yeah.
I was going to ask if that was the extra credit.
I'm sorry?
I was going to ask if that was the extra credit.
Yeah, and so that's how you get those 4 hours, is if you log in there. There's also, I think, a sign-in over here as well that you can do, or at the Tutorial Center. Tutorial Center has tutoring is there as well. They have drop-in stat hours. So that's the other place of getting help and getting questions answered. So here's a quick review. Additional rules of probability. How about Chris? Hey, go ahead and read.
Two events are mutually exclusive events or disjoint events if it is impossible for them to occur simultaneously. Exclusive means separate.
Yep, read the first addition rule.
Addition rules: probability A or B
Of A or B.
Probability of A or B equals the probability of A plus probability of B. Mutually exclusive.
Perfect, thank you. And Allie O, read the second one.
What's the second one?
Yeah, the second formula. Probability. Remember, capital P, guys. Capital P means probability. Parentheses means of. Get used to reading it that way. Go ahead.
The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A.
Right. So, in other words, if they have nothing in common, they're mutually exclusive. Like the probability you pick a red marble or a blue marble, you just add their probabilities. Right? Probability of A or B, red or blue, add their probabilities. If they have overlap, like the male puppies and the yellow puppies, then you add their probabilities, but then you subtract the overlap. Because the yellow and male puppies, right, the ones that are yellow and male, they're getting counted, and the yellow and the male, they're getting double counted. So you have to subtract off one of them, so they're only getting counted once. Great. The multiplication rules, let's have Stefan, go ahead and read the first one.
The
Probability.
probability of A and B equals probability of A times probability of B.
Good. If they're independent. So if they're independent, you just multiply the probabilities. Corey H, go ahead and read the next one down here.
Probability of A and B equals the probability of A times the probability of B given that A occurred.
Perfect. Great. So here, if they're independent, you can just multiply their probabilities. If they're dependent, then you have to first find the probability that probability of A happening. So assume that you've taken that step towards A on your tree, and then knowing A has happened, given A has happened, the probability of B happening given that A has happened, because you've already gone down that pathway. So, so if they're dependent, you can't just multiply the probability of B. It has to be the probability of B given that A has happened. So we'll talk a little bit more about that. So this is the first one. Remember last class? What's the probability I roll a dice and die and get a 4? What's the probability I get a 4? 1 out of 6, right? Okay, but however, what if I first flip a coin and I get heads, or I get tails? Now what's the probability that I roll a 4? Still 1 out of 6, because these two things are independent. They don't affect one another. So we know they're independent because these probabilities are the same. Please note this. I'm looking at the probability of 4, and over here I'm still looking at the probability of 4. They're both the probability of 4. This is the probability of 4 given nothing. This is the probability of 4 given the first I flipped a coin and got tails or heads or something like that. Make sense? So they're both probability of 4. This is probability of 4 given something else has happened. If they're the same, then that means that these two things are independent of one another. Because knowing that it was heads did not affect the probability of getting a 4. You guys are really quiet. Okay. Are yellow and male mutually exclusive? So what's mutually exclusive again? They cannot occur simultaneously. They can't happen at the same time. So yellow and male, you said they are not mutually exclusive. Why?
You can have a yellow male.
Yep. You can be a yellow male. Make sense? Are yellow and male independent?
No.
No. Why?
Because if you have information that it's given one, it gives you more information about the other.
Yeah. So here is the easy way on the exam of how to prove this. All you have to do is this. So yellow and male. Which things have to do with yellow and male? Which of these numbers have to do with yellow or male? This one? How about this one?
No.
Yes or no?
Yeah.
This has to do with yellow or male?
Male.
Well, this is male chocolate. If we're talking just male, then we'll be looking at this one. Is that, you guys kind of follow me? All right. So these two are not male, just male or male yellow. This is just male. What's the other thing I want? Yellow? Where's my just yellow?
6.
Okay, good. And then I have my total down here. I need to make a square or a rectangle. So I need this guy, my total, and I need, what's the other one I need? Yeah, the males that are yellow, my yellow males. Right, so just the yellows, just the males, the male yellows, and the total. Then I'm going to divide these. 4 divided by 6 is not equal to 12 divided by 20. That means because those two proportions are not the same, they're not equal, it's dependent. If they were equal, in other words, if the probability of male, 12 out of 20, was the same as probability of male given yellow, 4 out of 6, it would be independent. They're not equal, so they're dependent. Now you can't just write this. You do have to check and make sure these fractions are actually not equal. You'd have to use your calculator and say, okay, 4 divided by 6, all right, and 12 divided by 20, okay, this is 0.67 and this is 0.6. They're not the same. Because sometimes fractions don't look like they're the same, but they really are. Yeah.
Can you also put 4 out of 12 is not equal to 6 out of 20?
What was that?
Can you also put 4 out of 12 is
Yes.
not equal to 6 out of 20?
You can also put 4 out of 12 is not equal to 6 out of 20. You can absolutely do that. Yeah. Yes?
So if we just wrote like those fractions, like that would count as our explanation.
What the not
We wouldn't
equal
have
to?
to use any words.
Done. That's it. That's the simplest thing you can do. So this is telling me that the portion of of males of the population is not the same as the portion of males given yellow. Here's another way you can do it. So what was our formula for if they were independent? The multiplication, the probability for multiplication? If they're independent, probability of A and B, right? In this case, probability of male and yellow. So does probability of male and yellow equal the probability of male times the probability of yellow? That's the question. So what's my probability? What's probability there that you have a male and yellow puppy? Have a look up here. What's probability I get a male yellow puppy? Talk to your neighbors. 15 seconds. Probability of a male yellow puppy. If you're not talking to your partner, I'm more likely to call on you. Find a partner.
Wait, male yellow.
All right, Noe's like, call on me, I'm ready. All right, Noe, what is it? 4 out of, what'd you say? 4 out of 20. Right, there are 4 yellow males out of 20. So we know that this is 4 out of 20. I'm going to circle these things. Oh, actually, I'm not. I don't need to. Okay, what's the probability that they are a male? 12 out of 20, everybody on board with that? And what's probably that they're yellow? 6 out of 20. So that's the question. So 4 out of 20 is equal to 0.2. And if I multiply these, 12 out of 20 times 6 out of 20, I end up with 0.18. Are they equal? No. So they're dependent. Everybody okay with that part? I did that. So if they're independent, then this should equal that. If it doesn't, then it's dependent. Yes?
This might be like a weird question, but how do you know if you're using like the multiplication or the addition?
We're going to go through that a lot. Okay, so that's actually, we're going to cover that next few slides, I think. Like in the next 15 minutes. So we'll go through that a little bit more. So here's our first quiz. So first of all, well, that's okay. So here, this means union, right? Remember that guy with his arms open? I take everybody. A's and B's, you're all welcome. That's the or. That means that you're going to combine them. So or, if they're mutually exclusive, that means that what's their overlap? Do they have any overlap?
No.
The total?
Talk to your neighbors. If they're mutually exclusive, do they have overlap or not? Talk to your neighbors about it. Shake the cobwebs, focus. Okay. All right, so if they're mutually exclusive, do they have overlap? No, they have nothing in common. Everybody remember that? That's the idea. If they're mutually exclusive, they have nothing in common. No overlap. So it means that there's nothing in here. So if probability of A is 0.32 and probability of B is 0.54, then probability of A or B, this big part here, should equal what? 0.86. Probability of A or B is equal to 0.32 plus 0.54. Ors, you add. So that's the first part of what you're talking about. I can't remember your name, but that's the first part you're talking about. Ors, you add. And if you think about it, it makes sense because What's probably, you pull a blue marble or a red marble, you just add them, right? It's just more marbles. What's probably, I roll a 3 or a 4, you just add them, right? 1 6 plus 1 6. Okay, so ors you add. Do you guys want like 30 seconds with your neighbors to go over the last couple things we talked about?
Yes, please.
Okay, go ahead. Okay, you guys are digressing, I think. What's problem number 3? This one is and, right? You have to be in both. The bow-legged guy, you have to be in both A and in B. Right, that's and. That's the intersection. So here we have probability of A is 0.32, probability of B is 0.54, probability of A or B is 0.70. Find the probability of A and B. A and B, that's the intersection. That's the overlap. First of all, how do I know that there is overlap? Yeah, the problem kind of lends it to you.
Tells you it's an intersection.
Yeah, I guess it's kind of a good point. But here's the thing: if they're mutually exclusive, what should happen? If there was no overlap, how do I find the probability of A or B? Just add them. If I add A and B, what do I get?
86?
Yeah, is that the same as 70? No, so there must be some overlap. So let's go ahead and do that. So we know that this whole part here is 0.32. This whole part here is 0.54. And we know that this section here, if you add them all together, you're going to get 0.70. So we got to figure out there must be something in every we subtract. So here's the formula. Probability of A or B. I'll write down or so it's less confusing. A or B is equal to probability of A. Well, okay, so think about this. Think back to our puppies. The male puppies and the chocolate lab puppies. How do we find the probability of male or chocolate lab in that scenario? What do? We added what? Probability of A or B was what? How do we find it? What did you say? Yeah. So we did the total male, so probability of A, right? And then you said the total plus all the yellows. So it's probability of B. And then we did what? Yeah, subtract the overlap. The ones were yellow and, chocolate and male. Right? So we found it. We found the yellow males, the chocolate males, the chocolate puppies, the male puppies, and subtracted the overlap. So I have above some of these things, right? Looks like they gave me 3 of them. If I know 3 out of 4 items, I have 4 unknowns. Everybody follow? 1, 2, 3, 4 things I don't know. If I know 3 out of 4 of them, can I find the 4th? Yes, everybody do it. I'll give you guys, who needs like another 30 seconds to do this? You guys are all done?
Yeah.
Really? You're impressive. Do you have a question?
Yeah. So on like the question,
Uh-huh.
it has the UE and then the UE.
Yeah.
So the first one that we were supposed to find is facing down. So why isn't it P probability of A and B?
This is what we're trying to find.
No, I know, but that one in the equation is facing up. So why isn't that one like probability of A or B?
This is the N.
No, I know, but in the equation it's facing up. That's why I'm confused.
This one's up.
I see what you're saying. I see what you're saying.
Is the equation wrong? It should be this. Should be like that.
Yeah, but see, it says find the probability of
Oh, yeah, it's
B
reverse up top.
and B, probability of A and B.
I want you to find this. I don't want you to find that. I want you to find this.
But it gives it to us, doesn't it?
No.
No.
It gave you that. It gave you those three, not this one.
Oh, okay, gotcha.
So it gave you this one and that one, not this one.
Got it.
You need to find this one. So it's a little bit harder than normal, right? So I'll give you guys 30 seconds to kind of sort this out.